Um, Hello, Samuel.
Hi.
Yeah, hi. How are you doing today?
Oi. Aí vai vir essa e vai sempre. Ok? É? Beleza. You something there? Is it gonna eat something? You need to correct every masterpiece. I can tell you. No, 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 man. What? Did I eat something? Sí, es que me da lo mejor. Pues yo voy donde estoy donde estoy. Maybe.
Okay, alright, right. So let me present the screen. Did you try the questions, the remaining questions? Yeah. So in the last session we discussed till the 18th question. Yeah.
Oh, yeah.
So right. So did you try the 19th one?
Yeah, I did, but
Yeah. So what's the answer?
uh,
So what's the answer? Right. So did you find the answer? Shall we check if your answer is correct or wrong?
I got.
Okay, okay. Let me
I thought,
explain.
I thought, I thought you meant. I thought you said get the answers to the other paper. You said work on the one. I worked on the wrong paper.
Yeah. Okay.
It was a different. It was a different chemistry thing that I got on my study guide.
Okay. Okay. So let me explain now. An atom of the most common isotope, right? So what do you mean by the term isotope? Have you heard the term isotope?
Yeah.
What is it?
Is it an ion?
Yeah,
Is
isotope
it?
is a different forms of the same atom with different mass numbers, right? So here different forms, we can say different. Uh, no, okay, so we can say, right? For example, if you take a simple example, carbon 612, carbon 614. So here the atom is carbon, in both situations the carbon, but the atomic number will not change, but for the same atom the mass number may be different, right? So these are
Yes.
called isotopes. Yeah, isotopes.
Isotope.
Right. Now here they are telling the isotopes of gold, right? So the chemical symbol of gold is Au, aurum, right? Has this
Yes.
number of protons, number of neutrons, number of electrons. Now, if you know the mass number, now you should know the atomic number also in order to find the number of electrons, number of protons, and number of neutrons, right? So, what's the atomic number of gold?
This one I look at periodic table, right?
Yeah, right. Can you look at the periodic table and find the atomic number of aurum?
Uh, 79.
Here you can see 79, right? Gold, aurum, 79. So here let's go to our
And my teacher said on my exam we are using the periodic
Yeah,
table.
yeah, 79, right? So if the
Right.
atomic number is 79, what can you tell the number about the number of protons?
197.
The
The protons is it one is 118?
how? So we already discussed, right? For an element, atomic number is equal to number of electrons, which is equal to number of protons. Yeah, did we discuss this equation? For an element,
Mm,
number of electron will be equal to number of proton, which will be equal to the atomic number. So Z is equal to P is equal to E, right? I
right.
understood that. Right. So now, since the atomic number is 79, the number of protons also should be 79. So we can eliminate A and B. These two cannot be the answer. Right.
It's
So here,
either C or D.
yeah, COD. Now again, now look at the number of electrons. Here the number of electrons also should be 79. Yeah, 79 mean
Right.
here lastly we should have 79. So in the D only we have 79. So we can eliminate C also, right? Okay. So the answer is D. Now shall we confirm our answer by calculating the number of neutrons?
Yes.
Okay. How can you do that?
Add. Oh wait, hold on. Use a calculator. A 197 minus 79 is 118. So that's how we got the protons by
Yeah.
subtracting.
So the number of neutron is equal to A minus Z. So 197 minus 79 is equal to 118. Yeah. So here in middle we have 118. That is the number of neutrons. Okay. Right. And can you try the 20th one now? And have you understood the 19th question? Do you have any doubts?
Oh no, I had said D because I had said 180.
Okay, 118. Yeah. So that's okay. Fine.
Alright, 20 combination.
Okay, 20th one.
Which combination first calculate of isotope copper 63. Let's see. Right. Let's see. Isotopes of copper. I don't know how that's worked out.
Okay. So again, this is also similar to the previous question that we discussed just now. Yeah. Now, in the previous question we were talking about gold, but here we are going to talk about copper, right? So copper means Cu, right? So Cu is a 3D transition element. Now, from this atomic symbol, what are the things that you can extract? A is equal to 69, 63, and Z is equal to 29, right? So now they are asking the number of protons, right? So which combination of protons, neutron and electrons is correct for the isotope of copper? Now here, since the atomic number is 29, the number of electrons and the number of protons should be equal to 29. So here look at this 29 proton and 29 electron. That is the answer. Yeah.
And how did we get 29 again? Because we. Oh,
Right.
wait.
See this one. Okay, right. So here, for example, if you take a typical element x, right? So here we will have a, and here we will have z. So how do we call this z? Atomic number.
Atomic number. Uh-huh.
Atomic number. And how do you call this a?
Atomic.
Uh,
Is it atomic mass?
no, mass number. Yeah,
Mass number, yeah.
mass
Mass number,
number.
not atomic mass.
Right. So now for an atom, right? So for an atom, and we have two things, right? For an atom and for an ion. For an ion, right? For an atom, the Z atomic number is equal to number of proton, which is equal to number of electrons. Yeah.
Right.
And atomic number will be equal to number of neutron plus number of proton. These two equations you should bear in mind. And for an ion, atomic number will be equal to number of proton, but that will not be equal to number of electrons. Why is that?
Yeah.
Why is that? Because ions are formed by the adding or remove, either by adding or removing the electrons from the neutral atom. Yeah. Is in the previous class we discussed. Do you remember? How do you form ions?
Wait.
Hmm?
One more time. This is fun. One more time, please. This is my headphones.
Okay. Right.
What's it?
So okay. Right. So for example, Na plus. How do you form this Na plus? By removing one electron from the sodium atom. So here for an ion, that will not be, number of electrons will not be equal to the number of protons, which is equal to atomic number. Yeah. Okay.
Yes.
Right. Now if you apply this theory here, now they are talking about copper, right? So here instead of
Right.
X we have Cu, right? So let me erase all these and explain. Right. So here look at this question. Here this is atomic. This is mass number. 63 is mass number and 29 is atomic number Z. Right. So Z is equal to 29. So we have a relationship. Z is equal to P is equal to E. Right. So since
Right.
the atomic number is 29, the number of protons and the number of electrons also should be 29. Did you understand that now?
Yes.
So the answer should be A. Look at the other responses. Here 29p okay, but not 63 electrons. No. Because 63 is mass number. It cannot be equal to the number of electrons. And here 34 is also not correct. Here again 63 is not correct. And here also 63 is not correct. Why? Because the number of protons cannot be 63 for an isotope. Right? Here 34. Right. So the answer is directly A. Now shall we confirm our answer by calculating the number of neutrons? How can you do that?
Yes.
Simply
29 plus 34.
huh? No. So how do you calculate neutrons? N is equal to A minus Z. A minus Z. So what is A? This, the upper number or the subscript number, so the superscript number minus subscript number, right? So
Right.
here 63 minus 29. What is the answer?
Is it 46?
63 minus 29? Oh, can you use calculator in the exam?
Yes.
So you can use the calculator to find out. Otherwise, 63 minus 29, right? So we bring 1 from here. So 13 minus 9 is 4, right? And we have brought 1 from here. So the remaining is 5. 5 minus 2, 3. So what's the answer?
34.
34, right? 34. So here 34 neutrons, and you can see here the charges of positive is proton is positive, here neutron has no charge, so 0, electron negative charge. Yeah. So now you should know how to calculate the number of neutrons in an atom or isotope. So how do you do that?
You make it a negative?
Yeah, how do you calculate the number of neutrons? Simply mass number minus atomic number, which is equal to the superscript number. You can simply write like this: superscript number minus subscript number will give you the number of neutrons. Okay,
Yes.
right. Now can you try the 21st one?
Yes. So it will be 34, obviously, because we're subtracting it.
So what's the answer? A, B, C, D, or E? E. Why?
Well, because it's the
Yeah, 45 protons mean the atomic number should be 45. So the subscript number should be 45. So here in this answer only we have 45 as the subscript number, right? Okay. And now we will move to our 22nd question. Can you try to do that?
so yeah, it'll be E.
Yeah. Okay. So so have you studied about significant figures?
Oh yeah,
Okay. So what are
but I
significant
kind of
figures?
do have. Hmm?
What are significant figures?
It's like it's like how many are left, like after the decimal point.
Yeah. Okay, so I'm asking a definition for significant figures.
I don't know that much. I don't really know about.
Okay, that's fine. So significant figures, you can simply say the number of digits in a number that contribute to the accuracy of the measurement, right? So that will contribute to the accuracy of the measurement, right? So this is just a definition for that. Now here you can see how many. Now we have some rules and regulations for significant figures, right? So I have just okay. So here we will study this now. Okay. Right. So now you see significant figures. Significant figures. Now in scientific measurements are reported so that every digit is certain except the last, which is estimated. All digits of a measured quantity, including the certain one, are called significant figures. Right. So this is another definition. We can simply say the number of digits that can contribute to the accuracy of the measurement. Okay. Right. Now here we have some examples, right? All non-zero digits are always significant. All non-zero digits mean 1, 2, 3, 4 and other numbers, right? So the counting numbers. Now here you see in this number 1.54, how many non-zero digits do we have?
There's none.
Oh,
Oh wait,
there are 3.
there's
Right?
three.
So 1 is a non-zero digit, 5 is a non-zero digit, and 4 is a non-zero digit. Now if you have 0.003, how many non-zero digit do we have in this number?
One.
1, which is 3. And how many zero digits do we have?
Three.
3, right? So here the significant, we have 3 significant figures. And here in 45, how many non-zero digits do we have?
Two.
2. So the significant figure will be equal to the number of non-zero digits in a number, right? Okay. 45 has 2 significant figures. And the second rule is interior zeros, right? Interior zeros mean the zeros between 2 non-zero numbers, right? Non-zero digits. For example, here you can see these are called leading zeros, right? So leading zeros mean the beginning of a number. In the beginning of a number, do we have zeros? Those zeros are called leading zeros. And the zeros in between 2 numbers are called interior zeros, right? Interior zeros. Now, okay, now the interior zero here in this number is this 0, right? So they are also significant. They are also significant, so we will count them, right? So look, you see this, but leading zeros are not significant, right? So how many non-zero? Okay, look at this one. Right, now if I explain all the theories, then you can, right? So now you see leading zeros. What are leading zeros? Zeros at the beginning of a number. Here these are leading zeros, right? Here this is the leading zero, and here all these are leading zeros, right? Can you understand that?
Right.
Okay, so they are not significant. They are not significant. So in this number, how many significant figures do we have in this number? In this number,
You have 4.
4. Why? Because according to the first rule, we have to count all the non-zero digits, and the interior zero also should be counted. So we have 3 non-zero digits and 1 interior zeros. So altogether we have 4 significant figures. And here also 3. Why? Because interior 0 plus non-zero digits 2. 2 plus 1, 3 significant figures. And here how many interior zeros do we have?
6.
Huh? How many interior zeros do we have here in this number?
What? Which one? Oh. 2.
2, right? So they are bolded. Here you can see they are bolded, right? This 0 and this 0. And we have 1, 2, 3, 4 non-zero digits. So 4 plus 2, 6 significant figures, right? And here,
You count all of them?
yeah, we have to count all of them.
I'm so horrible at this. Alright, ready to continue.
Okay, right. And third one, the leading zeros are not significant. The leading zeros are not significant, right? So no matter how many zeros do we have in the beginning of a number, we will not count them, right? So here we will ignore this zero, right? And all these zero, we will not count them. So here we have three significant figures. Why? Number of non-zero
Well,
digits is 2, and here we have an interior 0. So three significant figures. And here we will omit all these zeros, and we have only one non-zero digit, so the significant figures will be 1, right?
right.
Okay. And trailing zeros mean zeros at the end. Zeros at the end, right? The opposite of leading zeros is trailing zeros, right? So zeros at the end of a number are called trailing zeros, right?
Trailing zero.
Trailing zeros, right? Like tail. So here we have two rules, right? Now they are significant. Trailing zeros are significant if and only if there is a decimal point present in the number, right?
Right.
Right. So in a decimal number, if we have zeros at the end, they will be counted as trailing zeros, but in any other circumstances we will not count them. Okay, right. Now you see here, this is a decimal number, right? So here we will consider this trailing zero as a significant figure. So according to our previous rules, this one, this interior 0 and this 5 are significant. In addition to that, this trailing 0 is also now significant. So we have 4 significant figures. Yeah.
Yes.
Okay. And here 1.00. Here the decimal place is present. So we will count these two trailing zeros. But here this is just an index, so we will not bother about this one. So here how many significant figures do we have here?
Oh, we have one.
How one? Will we not consider these two trailing zeros?
Yes,
Why?
because they're well, because they're at the end of the number.
Yeah, they are at the end of the number. But what do we say? If we have a decimal point, the zeros at the end of the number will be counted as significant figures. Yeah. So since we have decimal point here, we will count them, these two trailing zeros, as significant. So this is already a significant figure, and in addition to that we will count these two zeros. So altogether we have 3 significant figures, right?
Right.
Okay. Right. Now here it should be 10.0, right? So if you have 10.0, we will have 2 significant figures. Why? Because due to this 0, we will count this 0 as significant figures. Why? Because in a decimal point, if the decimal point is present, right? So here there is a typo. There's a typo. Here it should be written as 10.0. Okay, 10.0. Now see, right? So since we have decimal point, this is the last 0 that we have, but we will count it as significant figures. So we have 2 significant figures, right? But if you have 10, how many significant figure do we have here? If you have merely 10, how many significant figures do we have here?
Oh, then you don't have any.
We have only 1 significant figures. Why?
Oh yeah, and that's the yeah. The
Yeah,
zero
why?
right there.
Because here we do not have a decimal. This is not a decimal number. We do not have decimal
That's a whole
point.
number.
So we will not count the trailing zeros as the significant figures. So we will not consider this 0. So the only significant figure is this one. So here in 10 we have only 1 significant figures, but in 10 point here 2 significant figures. Why? Because since we have decimal point present, we will count this trailing 0 as a significant figure, right?
Right.
Okay. And here you can see, yeah, You look at these examples. Here we will not count these three zeros as significant figures. Why? Because this is not a decimal number. We do not have a decimal present here. So we will count only this one as a significant figure. So one significant figure. And in 190, how many significant figures do we have?
2.
2. Why? Because we will not consider this 0 as a significant figures. So we have 2 non-zero digits. So 2 significant figures. Right? Okay. The fifth rule is exact numbers have an unlimited number of significant figures. Right? So here, so this is not actually necessary for you. Right? Okay. You can omit the fifth. Right. Now in calculation we have some rules for applying in these significant figures. Give me a sec. Okay. So okay. Now if you add two numbers, two decimal numbers, now like for example, you see if you add two numbers with different significant figures, we have to add like regularly, like in the manner that we do regularly, but we will ultimately we have to round the answer to the lowest number of decimal places, right? To the lowest number of decimal places. You see here 2.0345. In this number, how many decimal points do we have?
1.
How many decimal points do we have? Decimal points, not significant figures. Significant figures are different from decimal points, right? So we abbreviate decimal points as DP and significant figures as SF, right? So here after the decimal point,
right?
4, right?
4?
1, 2,
Yeah.
3, 4. So 4 decimal
Yeah.
places. And here 0.07. How many decimal places? This
2
and
because
this.
you're going 1 and then 2 on into the 0, and that's in the middle. So it goes 1, 2. It starts from the 7 and it goes 2 times to be in between the 0 and the other 0.
Yeah, right.
Yeah.
Here there is a mistake, yeah, in the calculation. Okay, omit this one. I will explain the questions from here. Right. I will explain the theory from here. Right. Now let's do these questions. Okay, from you. Okay. Right. So can you try the 22nd one now?
Uh-huh. There's 3 significant digits.
3 significant figures, right? Why?
Figures,
Because
yeah.
the leading zeros will not consider. And how do you call this zero?
That's called it's the first one. It's called the one where you can count it because
Interior
it's with
zero.
interior, yeah.
Interior.
Interior,
In between two decimal place.
Yeah.
In between two numbers, right? And 23rd?
6 significant digits.
Okay, let me count. 1, 2, 3, 4, 5, 6. So 6, right?
Yes.
Okay.
Right,
And-
yeah. 6 significant
And how many
digits.
significant figures are in the measure? This.
3
3. Why? Because
because
these three
the interior
interior zero is 1 and these are 2 non-zero digits, right? And here
that one. B.
right. So properly round 0.02357 to three significant figures, right? So we should have only three significant figures, mean we should have only three numbers. These are three significant figures, and we have to look at the fourth significant figures here, right? So since this is greater than 5, we will add 1 in front of the digit before the number that we are considering. So 0.236, right? So the answer should be D, not C. Have you understood it now?
Yes.
Right. So
Now
rounding means we have a rule for rounding, right? So we have to consider the next digit that we have to round to, right? So here we have to round to three significant figures. So we will look at the fourth significant figure. And if the fourth significant figure is greater than or equal to 5, we will add 1 in front of that digit. And if this is less than 5, we will keep it as it is. Yeah. So here, what is the fourth significant figure? That is 7. So 7 is greater than 5. So we will add 1 to this 5 and write as 0.0236. Right? Fine?
Right. Now I understand. Yeah, that one's good too.
You
It's good that I
understood now?
started to. It's so good. It's good that I started to understand the significant figures.
I'm sorry?
Yeah, it's good that I started to understand the significant figures.
Yeah. Okay. Shall we move to the 26th one?
Yes.
Okay. Right. So the answer to the following math problem, right? Rounded to the correct. Okay. Now you see here, when we multiply two numbers, we have to multiply, right? We have to multiply according to our own method, usual method. Now, if you multiply these two numbers, we get 9.18. So using a calculator, can you confirm whether you get this number?
Let me see. By that's rounding, so it'd be C.
C. Why? Because we are supposed to round to the correct number of significant figures, right? So here,
Right.
when we want to round to the correct number of significant figures, we should, okay, now you see, we should have to correct to the less number of significant figures, right? So when we multiply,
Right.
so here we have three significant figures, and here we have two significant figures, and the answer also should contain the lowest number of significant figures that the number contained that we multiply, right? So here, now 2, the answers also should be correct to the two significant figures. So we have to look at the third one. So we have to just add 1 to the previous digit. So 9.2.
Right, and it'll become 9.2. Now I'm getting it.
Yeah, that's fine. And what about 27th one?
That one I got. Hold on. Let's see. Round.
Okay, so there is a thumb of rule, right? If you are multiplying or if you are doing any mathematical operation, the final answer should contain the significant numbers with the lowest value, right? So now we are operating two numbers with two significant figures. So the final answer should contain the significant number of less number of significant numbers that we initially operated, right?
Alright. Let's see. It's D, right?
Let's see. So Right. So this is the answer and correct number of significant figures. So how many significant figures do we have here? 5. Here also 5. So
Five.
the answer should be 5. So 1, 2, 3, 4, 5. So look at this one. So add 1 here. So 119.13. So the answer should be C. Okay.
Oh yeah, because we're rounding and we're changing it to we're changing the number.
Yeah, we are
That
changing. Yeah,
yeah.
we are changing. Right? Why? Because 5. Now the final answer also should contain only 5 significant figures. But now we have 6 significant figures. So we have to look at the 6th significant figure, and if it is greater than 5, we have to add 1 to the previous digit. So 119.13. Okay, right.
Can I go? Can I get my dinner? That's right there, real quick.
I'm sorry.
Can I go get my dinner? That's right there.
Okay.
That I can bring over here. Yes, ma'am. Hello.
Okay. Right. Right. Fine. So here in the 28th question, can you try to do that?
Yep.
28th one.
It'll be. I can cross out the rest of it, but I think it's
Suppose 5 grams of hydrogen, right? H2. 5 grams of H2 is reacted with 25 grams of oxygen, O2, right? So according to the law of conservation of mass. So what do you mean by the law of conservation of mass?
so that means subtract.
Hmm. Right. So have you heard about the law of conservation of mass?
No.
Okay. So when we are performing a chemical reaction in a closed system, the mass of the reactant should be equal to the mass of the products, right?
Right.
The mass is conserved. There will be no addition or reduction in the mass. Now here we make water by reacting H2 gas and O2 gas, right? So the yield is, what do you mean by yield or product is water, H2O.
Water.
Now here we have 5 gram of hydrogen and 25 gram of oxygen. So what is the total mass of the reactants?
30.
30. So the 30 gram of water should be produced, which means the products, the mass of the product should be equal to the mass of the reactants. So since we have 30 gram of reactants, the water that we produce should have 30 grams. So what's the answer?
Grams.
What's the answer?
The answer is 30 grams.
B, right? How much water should form? 30 gram of water should be formed, right?
Right.
Okay. What about 29th one?
The mass of a beaker. That's I don't know. Wait, but I know what that's about. Quantitative or qualitative?
Yeah, so here we have two types of measurements, quantitative measurements and qualitative measurements, right? So quantitative means it's an adjective derived from the word quantity, right? Quantity, and qualitative means quality, right? Quality. Now quantity can be measurable, right? So it will have
But
values, right? It will have values. The quantitative measurements will have values, but quality means, we cannot measure it. For example, the beauty, right? Beauty, right? Satisfactory level. So highly satisfied, moderate, not satisfied at all. Likewise, we have categories, right? So it quality means the features, right? So we can say features. Now tell me the answer according to this idea.
that one is quantitative.
Quantitative. Why? We are dealing with number, 45 grams. So number is there, right? So values or number. If you have values or number in a measurement, that will be called quantitative, right? So the answer is A. Okay. Right. Now 30th one. Can you try the 30th one?
Is it I saw on my periodic table. Is it bromine?
Okay. So you can look at the periodic table. So what's the answer?
Bromine.
Bromide. Fine. So halogens group are the 17 group elements, right? So if you go to the periodic table, here all these elements coming in this group are called halogens, right? Halogens. So it comprises fluorine, chlorine, bromine, iodine, astatine, and so this is not necessary for you. Okay. Right. So which element is found in the halogen group, right? Group 17 elements, right? So you can see here group 17, right? So first, second, third, fourth, and this is called 17, and this is 18th group. Okay. So we will have to study about the classification of periodic table later. So the answer is bromine. And now 30th one. No, 31st.
Let me look at my periodic table. Ooh. Nitrogen.
Nitrogen. Right. So which of the following is a noble gas? Right. So noble gas means they are called inert gases. Right. Inert gases. So inert gases mean these gases do not involve in don't involve in chemical reactions. Chemical reactions. Right. So why? Okay, now 18th group elements, right? So the last column in the periodic table is called noble gas group, right? So here in the periodic table, these are called noble gases. How do you call this? Noble gases, right? So what's the answer now? These are called noble gases. Why? Because they don't involve in chemical reaction. Because in the valency shell, they contain 8 electrons. So they will not remove or accept electrons because they are filled. They are satisfied octet rule. So they will not remove or accept electrons. So they will not involve in chemical reactions. Right? So that's why they are called inert gases or noble gases. Right?
Right.
Have you understood?
Yes. So it's not nitrogen.
Not nitrogen. So what's the answer?
It's neon.
It's neon, Ne, right? So
Yeah.
iodine is a halogen. Iodine is a halogen, right? So we have
Right.
studied two specific or two special names that we give for the last two columns in the I can't. Sorry, right. So iodine is a noble. I'm sorry. Iodine is a halogen, right? And neon is
Right.
noble gas. And what about the 32nd one?
Let's see on my periodic table. My periodic table. It's D, phosphorus.
This one?
No, D,
Right.
phosphorus.
So group 15 or period 3, right? So
No,
the
it's
element corresponding to the group
it's
15 and period 3, right? So do you know about groups and periods in the periodic table?
it's
Right. So groups are columns. Groups are columns and uh, periods are periods are rows, right? Periods are
gross.
rows. Now here this is the first group, second group, third group, fourth group, fifth group, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18, right? So now 15th group means it should be here. It should be here. And the rows are called periods, right? So this is the first row. So first period, second period, third period, fourth period, 5, 6, 7. So in the modern periodic table we have 18 groups and 7 periods, right? So now in the 16th, in the 15th group, and third period, right? Third period. So what's the element here?
Phosphorus.
Phosphorus. So
D, 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 D.
so the answer is phosphorus. This one, right?
Phosphorus.
Understood? How to find the answer for this question? Yeah. Okay. Right. And which of the following is a metalloid? Right. So have you heard about the term metal, metalloid and non-metals?
What happened?
Yeah. So have you heard about the term metal, metalloid, and non-metals?
Yes.
Okay. So what are metalloids? What are metalloids?
Uh.
So what's the answer for the
Oh,
third one?
B.
Huh?
It'll be B.
Is zinc a metalloid?
No, A.
A. Silicon is a metalloid, right? So here we
Right.
will discuss this 33rd question in detail in the next class. So I think I have to stop now. So before wind up the session, do you have any questions to ask?
Yeah.
Okay,
You.
you can go ahead with your doubts that you have. You have any questions?
Oh no.
Okay.
This today's session was good. I did learn.
Yeah, what did you say?
I did learn about. I did good on the significant digits part too.
Yeah, and we talked about some of the properties of periodic table, right? And you can try
Right.
the rest of the question. We have only two questions remaining in that worksheet, and probably we will finish off with the two questions in the next class, and we will try some more questions, right? I will bring some more questions for you in the next class. That will be tomorrow, right?
Right.
Okay. And did you get the PDF of the previous class lecture material via email? Yes.
Yes.
Okay. And I'll try to send this one also, and along with the feedback and suggestion. And did you send the PDF no, feedback about the previous session, the first session?
Oh, I forgot to do it. Could I do it could I do it and send it to you after?
Yeah, yeah. Okay. So it doesn't matter. I will send the feedback. Okay. So right. So we'll wind up. Bye.
Right.